Good morning, Saintsmen, and welcome to Algebra 1. This is our first lesson for the Algebra 1 class. This is the Twitch stream for Lesson 1.1 for solving simple equations. We're going to go through a few things in particular, what I'm going to need to see from your work as you guys are doing this. I understand, gentlemen, that many of you are wonderful at mathematics and that you understand when you see this problem, what the answer is instantly. In fact, if you don't, you probably shouldn't be in this class right now, okay? X plus 1 equal to 3. The key here is not that you just know what the answer is. The key is the process that you're going to demonstrate. You have to show every step here, and it's going to take some time, and it's not busy work. It's for us to get through the demonstration of the process, because we're going to build upon these skills each day. So I understand that many of you understand that the answer is 2, okay? Excuse me, that x is equal to 2. But in order to get there, we're going to use the inverse operation, meaning that we're going to subtract 1 from each side. When we subtract 1 from the left side, it's going to cancel out the positive 1. So I'm going to have x, which is equal to 3 minus 1, which is 2. And I always need you guys to circle your answers. Okay, moving on. We're going to see a couple other things today. It's going to be a review of when we're going to have to deal with this while using fractions. D minus 1/4 is equal to negative 1/2. So, again, our process, in order to get D by itself, we have to follow the inverse operation. We're going to add 1/4 from each side, which will cancel out the 1/4 on the left, giving us D equal to, and then we have to do its own independent operation. I'm having a lot of trouble with my stylus here today, guys. I need to perhaps invest in a new one here. But negative 1/2 plus 1/4, and for those of you guys, you're going to have to remember how to do these fractions. You're going to need common denominators, right? This guy, negative 1/2, is equal to negative 2/4 plus 1/4, right? Since you have common denominators, of course, that is the 4. Okay, it's going to stay the same. And then I just need to combine the numerators, negative 2 and positive 1, which is a negative 1. So my answer is negative 1/4 is what D is equal to, or D equals negative 1/4. Next, I have M plus 4.8 equal to 9.2. Again, I need to get M by itself, so I'm going to perform the inverse operation. Gentlemen, this is the minimum I need to see from your work on these problems. If I do not see this much, you will not be receiving credit. I'm going to subtract 4.8 from both sides. I now have M is equal to 9.2 minus 4.8, okay? So remember, we're going to have to do some borrowing here. I'm going to borrow from the ones for the tenths, okay? I'm going to have 12 minus 8. The decimal place is going to stay the same. That's going to be a 4. And then I'm going to do 8 minus 4, which is 4. So 4.4 is our answer. All right. Moving on. We can also perform the same thing, not just using addition and subtraction, but we can also perform the same thing doing multiplication and division. So for example, if I have M over 5 equal to negative 4, in order to get M by itself, I'm going to wind up multiplying both sides by 5. The 5 and the 5 are going to factor out. M is going to equal whatever the product of negative 4 and 5 is, which in this case is negative 20. Again, what I'm illustrating here in terms of the steps is the minimum I need to see from your work. It's worth saying over and over. Okay. Next. For example, if I have 3p is equal to negative 2/3. Well, I would be able to employ 3p equals to negative 2/3 to get p by itself. Since p is being multiplied by 3, the inverse operation would dictate that I'm going to have to divide. Now, here's where we have a problem. You have to remember how this works. The 3 and the 3 are going to factor out. P is by itself, but I have negative 2/3 divided by 3, and this is where many students get tripped up, okay? Remember, when you are dividing by a fraction, in other words, I have negative 2/3 divided by 3, I'm really multiplying by the reciprocal of the divisor, the second term that is listed. So I'm going to multiply, instead of 3, the reciprocal is 1/3. Multiplying fractions is pretty straightforward. Numerator times numerator to get negative 2. Denominator times denominator. So 3 times 3 to get 9. So my answer here is P is going to be equal to negative 2 ninths. Sure, my P is a lot clearer here for you. Further, I could even do this with symbols, right? Let's say I'm solving for x. And our directions here is going to be to solve for x. Well, to get x by itself, I have a funky little symbol that's being written here, and this is the Greek letter pi. Well, if there were a 3, right, it'd be 3 times x and then 9 times 3. I would just divide by the 3. But here it's pi, so nothing really changes. Since I'm multiplying, to undo it, I have to divide. So here, pi is going to factor out. If you have the same thing on the top as the bottom, it's equal to 1, so it factors out. Same thing over here. So x in this case is equal to 9. Okay. Let's do a word problem. Actually, we're going to do a couple word problems and we'll be done today. So, you clean a community park for 6.5 hours. You're going to earn $42.25. We're going to write and solve an equation to find how much you earn per hour. Okay. In this case, when you guys are talking about wages that you earn, okay, wages are earned by a wage rate times a time, and that's going to be the overall earnings. So, what we have is 6.5 hours that we need to multiply by however much we are going to earn per hour. So we're going to call that R. It's the rate. For example, if I worked for 2 hours, I worked for 6.5 hours. If I were to earn $2 per hour, I'd have $13, right? But in this case, I earned more than 13 bucks. I earned $42.25. My next step is I'm going to divide. Okay, so I need two things. One, I'm going to need you to provide that. That's the equation that we had to create. How we solve it, r is now by itself, 42.25 into 6.5. Okay, so I think you guys need to go back to remembering how to do that problem. .25. We're going to have to move this decimal one time, move it one time. That new decimal is right here. We have to figure out how many times 65 goes into 422. Okay? If it were 7 times, it's probably going to be too much. I think it's actually going to be 6. Let's multiply it back. 6 times 5 is 30, so 0, carry the 3. 6 times 6 is 36, plus 3 is 39. Now we subtract. We have a 2 and a 3, so 32. And now we bring down the 4. How many times does 65 go into 324? Well, let's give it a shot. 324. Guys, I'm sorry that I wrote it that way. That's should be a 42.25. That was a clerical error on my part. I just miswrote. So 65, right? Because we moved the decimal. How many times does it go into 325? 60 goes into 300 about 5 times. So let's try that. So 5 times 5. Carry the 2 in this case. 5 times 6 is 30, plus 2 is 32. So then that is going to be our answer here. This is 6.5. Which means it's a rate of money. So $6.50 per hour. And the last thing that we have here is a discounted concert ticket is $14.50 less than the original price, P. You pay $53 for a discounted ticket. What is the original price of the ticket? Well, the original price, it's going to be our model we're going to make here. It's going to be the original minus your discount is going to be your new price. So my original price, which I don't know, right? It's P. Minus the discount, which they say is $14.50, is equal to 53, the new price. How do I solve? Well, I'm going to wind up adding, right, to get P by itself. $14.50 to both sides, right? Make sure that I show my process. That's the most important part of this, is showing the process, showing the original model in the equation, and then how we actually proceeded from there. So 53 plus 14.5, right? So that's going to be 67.50, or the original price was $67.50. Look, having a lot of struggles here with the stylus today. I think it got damaged while it was in my briefcase, so I'm going to have to do some work on that. But gentlemen, there you go. Your assignment for this problem set is posted on Canvas under assignments, and have a wonderful day.